Okay, here is the answers to 6, 7, and 8. Notice, class, that the sine of one angle is going to be the cosine of the other. Okay? I want to take some time to talk about number 6 and number 7. Okay? Notice that they are equal to each other, and they're equal to each other because if we label angle D, right, from the viewpoint of angle D, 7 is your opposite, 24 is your adjacent, and this hypotenuse will always be 25, right? That will never change. So in terms of angle D, those are your labeling. In terms of angle F, the only thing that changes is your adjacent side now becomes your opposite, and your opposite side now becomes your adjacent, right? So those two flip, right? Adjacent and opposite, and adjacent and opposite, right? And remember what sine and cosine, the ratio, what that equals? Sine is equal to opposite over hypotenuse, and cosine is equal to adjacent over hypotenuse. The hypotenuse for both are the same number, right? And the only thing that changes between them is the actual changing of opposite and adjacent, right? So this change here reflects this change here. Yeah? So since they're the same, the sine of one angle will always be the cosine of the other angle. Okay? And for now, we're only doing this with acute angles. We're never, ever, ever going to be looking at it from the 90-degree angle. Okay? All right. Now what I want to do is go to this. And you guys see sine, cosine, tangent. Sine is here. Cosine is here. And tangent is here. We are going to be using these buttons. Okay? We are also going to be using the inverse buttons. Okay, on your iPad or iPhone, it says A cosine or A sine or A tangent. That's the same thing as sine of the inverse sine, inverse cosine, or inverse tangent. Okay? So we're going to run through some examples, and we do need our calculator for this. All right? Some things about a calculator first before we head into there's only one thing you got to check on your calculator is that it's in degree mode. Okay? If on your phone or iPad or whatever you're using, on the bottom left-hand side of the screen, if it says rad, right? Right here. Yeah. Then you're in radian mode, and we're not going to touch that topic, and you don't learn about that topic until next year. Okay? So don't worry about that, and just make sure you're hitting this button here. Yeah? And make sure that that rad goes away. Okay, on the screen itself. Now you're in degree mode, and you're ready to go. Okay? All right, so let's first, which segment is adjacent to angle Z? Right? Which segment is adjacent to that? Well, this is your hypotenuse. This is your opposite side, and this is your adjacent side, so it has to be LZ. Right? Simple, easy. Which segment is the hypotenuse? Hypotenuse will always be opposite the 90-degree angle, so it's NW or WN. Okay. Express each trig ratio as a fraction in terms of the simplest form. So the cosine of H. Well, if H is what we're looking for, opposite the 90-degree angle is your hypotenuse. Opposite angle H is your opposite side, and the last side is your adjacent side. That's how we're going to label throughout this whole trig unit. Cosine is ka, right? So it's adjacent over hypotenuse, which is 5 over, 13. Yeah. 5 over 13. Sine of I, really quick, what is the sine of I? 5 over 13 as well, because of what we just talked about, right? Before the calculator bit. And they are equal, right? So if you click that, are equal, are not equal. Okay. Cosine of P. So angle P is right here. Opposite the 90-degree angle is your hypotenuse. Opposite this angle is your opposite side. Next to it is your adjacent side. Cosine of P. Cosine is ka again. So it's square root of 39 over 20. Right? Adjacent over hypotenuse. Sine of O. Let's say you didn't know. The sine of O, this is your opposite side. This is your adjacent side, and your hypotenuse stays the same. Right? So the sine of O is opposite. Sine is so. So it's going to be opposite over hypotenuse, which is the same number, square root of 39 over 20, and they are equal. Okay. Simple for now. In a right triangle, ABC. So in this case, I'm going to draw it out. There's no diagram, so I'm going to make one. Okay. So that's my triangle. Angle A is 90 degrees. Cosine of B is that equation. And the sine of C is that expression. Solve for x. What do we know about cosine of B and sine of C? They're the same, right? Cosine of P and the sine of O, they're always going to be equal, right? If the two adjacent angles, or not adjacent, acute angles in a right triangle, their sine of one, cosine of the other will always be equal. Always, always, always. Okay, so we just make them equal to each other. Tan x plus 0.86 equals 5x plus 0.01. Okay, because I know the cosine of B is equal to the sine of A. So if I subtract 5x, five x plus 0.86 equals 0.01. I'm actually just gonna multiply everything by 100. If I do that, that's 500x plus 86 equals 1. Subtract 86 on both sides. (500x) equals negative 85. Divide by 500, right? And just solve for this. Negative 17 over 100. Yeah. That would be your answer. Okay. Cool. Okay, just set them equal to each other. And now we're going to get into tangent. So we got to figure out what the tangent of G is. Remember, whenever we're trying to figure it out, your first move is to label. Label, label, label. Okay, that's your first move. So hypotenuse will always be opposite the 90-degree angle. Angle G is here. Opposite that angle is your opposite side. And this is your adjacent side then. Tangent is TOA in SOHCAHTOA. So it's O over A. So tangent equals opposite over adjacent. So that's 32 over 24, but they want it in simplest form. Divided by 4, 6, 4, right? 8, 8. So that's 4 over 3, right? Cool? All right. Try this one. Tangent of Q is going to be equal to square root of 20 over 7. Square root of 20 can be broken down into 2 square root of 2 square root of 5 over 7. Okay? All right. Let's do this one. Find the exact value of cosine of J. Okay, so we're looking for the cosine of J. So in terms of angle J, opposite the 90-degree angle is your hypotenuse. Opposite angle J is your opposite side, and that's your adjacent. Cosine is adjacent, 6 over your hypotenuse, square root of 46. So square root of 46 is the simplest form, right? We cannot take anything out because that breaks out to be what? 2 times 23? And 23 is a prime number, so we're done, right? So here, we have to rationalize the denominator. You guys remember doing that? So this one's, if I multiply, how we rationalize this denominator of 6 over square root of 46, we're going to multiply both top and bottom, or denominator and numerator, by square root of 46. Okay? So this would be 6 square root of 46 over 46. And the 6 and the 46, they both go into 2. So then this would be 3 and 23. So then your answer would be 3 square root of 46 over 23. That's your answer. Now here is like the foundation of finding missing stuff. Yeah. So now we know how to label, correct? First step is to label, always. So opposite the 90-degree angle is your hypotenuse. And now since I got that 65 degrees, I'm going to use it. Okay? So since I have n at 65, opposite that is my opposite side. And this is my adjacent side then. Correct? That's how I'm going to label, correct? Yeah. Okay. Now, I want to figure out my x value. Right? I want to figure out my x value. And I know my adjacent side. So I think to myself, what trig function deals with adjacent and hypotenuse? Cosine. Yeah, ka. So here, this is where memorizing so, ka, toa comes in handy, right? So you guys see the pink circles? I've circled A and I circled H. So you guys look at the SOHCAHTOA, and it's this guy that has A and H, right? So I know that the cosine of 65 degrees equals adjacent 4 over hypotenuse x, right? Questions on my equation right there? No? So I just got to solve this, right? I just got to solve that. So in order for me to solve it, if your variable, this is a pro tip. If your variable is on the bottom in the denominator, all we got to do is just switch those two. So x is equal to 4 over the cosine of 65. Okay? Huh? All right, and then we are going to and then to solve this, 4 divided by the cosine of 65, 4 divided by cosine of 65. 9.46. Yeah. Round to the nearest tenth. That's 9.46. So 5. 9.5 it is. Okay. Let's try another one. Ooh, let's try this one. Now our x is an angle measure, right? So first things first, I have to label. This is my hypotenuse. From that angle, angle N, this is my opposite, and this is my adjacent, right? So you guys see that we know our hypotenuse, we know our adjacent side, and we have to figure out what this angle is, right? So what deals with hypotenuse and adjacent? Cosine again, right? So it's going to be the cosine of this x degrees equals adjacent over hypotenuse, which is 9.1 over 15. Right? Okay. And class, mathematically, how to get rid of this cosine is we have to take the inverse of that. Okay? So it's going to be 9.5 over 15. 9.1 over 15. All right? So essentially, class, what the inverse does is it tells us the angle. Okay, we got to figure out what the angle is. Okay? If we know what the ratio is, and we're going to figure out the angle, we're going to use inverse cosine. That's 52.7. So we go back up here, 52.7, so 53 degrees. Okay, I want you guys to try this one. Okay, so the first thing we have to do is label, right? Opposite to hypotenuse, or opposite to 90-degree angle is your hypotenuse. It's this angle that we're looking at. Opposite that is 9, and this is your adjacent side. So what deals, before I even say that, I have my opposite, I have my hypotenuse. What deals with opposite and hypotenuse? The sine. Sine. So sine of this angle, x degrees, is equal to 9 over 18, which is 1 over 2. So on your calculator, you need to put the sine inverse of 1/2. Okay, and now you are going to learn later on that that guy is 30 degrees. Okay? And you guys can do all the verifying that you want. Yeah, on your calculator, push second, and then sine. It depends on what calculator you have. If you have the TI-30X, this one, you have to put the angle in first. And then put the sine. Okay, the second and then sine. 1/2, I'll verify it as well, it's 30. Okay? That is the lesson for today. There is a little other part to it, which I'll get to later on. Thank you very much.